All righty, folks. We got our second to last video here in trig, and then we will clean it up a little bit with some limits after this. But today we're going to talk about something called polar coordinates. And unlike vectors where r was the magnitude and theta was the direction, or complex number where r was the modulus and theta was the argument, amazingly for polar coordinates, r is the radius and theta is an angle. So we don't have to change names on this, but it still does the same thing. The way polar coordinates work is it's all based off this idea of a pole. And when I say a pole, what I mean is it's essentially this idea that we have um, a pole that goes out to 0, and then we have all these concentric circles. So when we are dealing with an r value, that r value here tells you how many concentric circles out. So in other words, we want a radius of 5. And 2 pi over 3 tells you what angle. So if I'm looking at this here, the first thing I do is I find 2 pi over 3. I deal with the angle, and I'm going to count out 5 concentric circles or out on the 2 pi over 3 line. So 1, 2, 3, 4, 5. This would be the point 5, 2 pi over 3. So we don't have to get too terribly crazy with it. Why don't you guys do me a favor? Why don't you guys go ahead and graph 6 and let's try 7 pi over 4. Go ahead and graph that. Let's make sure you guys all know what you're doing. So go ahead and pause it for a second. All right, let's see how you guys did. So I'm going to find 7 pi over 4. It's right here along this line. So I'm going to count out 6. So 1, 2, 3, 4, 5, and 6. So there's 6 circles out along the 7 pi over 4 direction. Now, when we're dealing with polar coordinates, we can still have negative angles. So a negative angle is basically any angle that goes around clockwise. But we also can have something called a negative radius. In other words, this is when we say negative radius, we call this shooting the pole. So say this was the point -5, 2 pi over 3. So if you're looking at it, here's 2 pi over 3 right here. So instead of counting out towards 2 pi over 3, I'm going to go backwards along this line. I'm going to go backwards along this line. Instead of going forward towards 2 pi over 3, I'm going to go backwards 5 spots. That's what is meant by -5. So it's like 2 pi over 3 continues all the way down, and eventually 2 pi over 3 is the same one as 5 pi over 3. So if I was a positive radius, I'd count out towards 2 pi over 3. But negative radius, I count backwards. So if it was a -5, 2 pi over 3, that would be 1, 2, 3, 4. I'm going backwards. So even though I'm going towards 5 pi over 3, I started at 2 pi over 3 and I went backwards along that red diameter. So we can have a negative radius on these sorts of problems. So why don't you guys do me a favor? Why don't you go ahead and try to graph -4, 11 pi over 6. Let's see how you do. All righty, let's see this here. To begin with, we have 11 pi over 6, so that's right here. So I'm going out towards that direction. So I'm going out towards 11 pi over 6. But since my radius is -4, I'm going to go backwards. And when I go backwards, that's going to put me out, honestly, towards 5 pi over 6. So I'm going to go backwards. So 1, 2, 3, 4. I went backwards. So that's -4, 11 pi over 6. Why don't you guys do me a favor and see if you can come up with 3 different terms or 3 different ways to express -4, 11 pi over 6. Well, here's one way I see it. Another way to think of it is it could have been 4, 5 pi over 6. That would have given me the same point. What if I went just negative all the way around? If I went negative all the way around, 5 pi over 6 is equal to -7 pi over 6. So 4, -7 pi over 6 also would have been that same point. And if I wanted to go back to what I had originally, the angle that's equal to negative 11 pi over 6 would have been negative pi over 6. So I just subtract 2 pi from it. So another way to think of this would have been negative 4 negative pi over 6. Notice I have a negative r positive theta. I have a positive r positive theta, positive r negative theta, and negative r negative theta. So there's 4 different ways that I can use to rewrite every single point. So say I give you this point right here, this negative or 2.1 negative 5 pi over 4. Could you come up with 3 different ways to represent it? All right, so first thing I'm going to do is I'm going to figure out where that point is. So negative 5 pi over 4. So that would be, if I add 2 pi to it, that'll tell me where it is on my axis. So negative 5 pi over 4 plus 2 pi. That's going to be a positive 3 pi over 4. So I'm dealing with the point at 3 pi over 4. And 2.1, so I'm going out 1, out 2. 2.1 would be right about there somewhere. So that's the point I'm looking at. Nope, I lied. That is not the point I'm looking at. Let's just move that over there onto 3 pi. There we are. Okay, so we're trying to come up with 3 different ways. Well, in my mind, the most obvious way is when r and theta are both positive. What about if r was negative? So let's see, it's on the same line as 7 pi over 4. So what if I made it a negative 2.1 and 7 pi over 4? That would put me at 7 pi over 4, and then I'm going backwards. And then if I wanted to do the negative angle to 7 pi over 4, that would have been negative pi over 4. So we're using this idea of shooting the pole. Shooting the pole means to go backwards. So again, just to kind of think of where that's at, here's 7 pi over 4. And so if I'm going backwards on it, that's basically saying, all right, I'm just going to slide myself backwards as I shoot backwards along the pole. So there's that negative 2.1 at 7 pi over 4. So we have this idea of being able to graph coordinates and how every coordinate on this polar graph is really nothing more than just, it could be written as in 4 different ways. So now we're going to get to the idea of being able to convert back and forth from polar to rectangular. And notice, friends, nothing's changing, right? All our same stuff still applies. X squared plus y squared is still r squared. And if I wanted to, I could go further than that and say the square root of x squared plus y squared is r squared. Right? Just like we had with the modulus, just like we had with the magnitude, that's still the same. Notice tan theta is still y over x, just like it was b over a with complex numbers, just as it was y over x with vectors. Everything is still the same. Nothing's changing here. So if I want to change from polar to coordinate, it means I'm going to go from r to theta, and I'm going to figure out what it is in terms of x and y. So x is r cosine of theta. So that means r, which is 6, cosine negative 4 pi over 3. So that's the same thing as 2 pi over 3. So cosine of 2 pi over 3 would be negative 1/2. So 6 times negative 1/2 would be negative 3. And then we can do the same thing with the y value. Y equals r sine theta. So that means that y then is going to be 6 times sine of negative 4 pi over 3. And again, that'd be 2 pi over 3. So sine of 2 pi over 3 is root 3 over 2. So we have 6 times root 3 over 2. So that means that y equals 3 root 3. So if I wanted to write this in rectangular form, this would be the point negative 3 comma 3 root 3. So why don't you guys do me a favor? Why don't you go ahead and figure out what the next one is here. I'm going to rewrite our notes over here since we're using these today. While I'm doing this, go ahead and solve the problem here. I just want to make sure we have all this. All righty, so you guys are still in the process here. You probably have already finished it up, so you guys are ready for me to go ahead and deal with this. You guys are being good sports as I rewrite this here because I have a feeling I'm going to need this for everything else we're doing here today. All right, so I have my R value, I have my theta. So that means then that X is going to be R cosine of theta. Cosine of pi over 2, that would be the same thing as 0. So X equals root 7 times 0, which is 0. All right. Now we're going to go ahead and figure out what y is. So y equals root 7 times sine of pi over 2. So y is root 7 times 1. So y is root 7. So that means this point right here is equal to 0, comma, root 7. So we're going to keep going here a little bit as we go on our merry little way here. We've converted from polar to rectangular. What if we wanted to convert from rectangular to polar? Let's see what you guys can do with that. Take a look at example 6 there. I'd love for you guys to go ahead and convert that from rectangular to polar. All right, so we've already been doing some things kind of like this already. We did this in vectors. We did this with complex number. Still the same thing applies. Graph the point. Root 3 negative 1. That's going to be right about here somewhere. So that means I know I'm dealing with some sort of angle in quadrant 4. So let's go find our R value real quick. So root 3 squared plus negative 1 squared. So R is the square root of 3 plus 1. R is the square root of 4. That means R is 2. And then we're dealing with tangent now. Tangent of theta is y over x. So if I were to rationalize, this is the same thing as negative root 3 over 3. So tangent of theta is root 3 over 3. So that occurs in at 5 pi over 6 and 11 pi over 6. So looking at our, now we can look at our point to figure out which one we actually want. It's in quadrant 4, so that means we are going to use 11 pi over 6. Oh, dealing with that then, friends, that means this point right here is the same thing then as in polar form as 2 11 pi over 6. And friends, I think it'd be good to try another one of these here. So even though it's not on your notes, find a place and include it on your notes here. What if I give you the point? No, let's try root 5 or negative root 5 and negative root 5. Do me a favor. I would love to know what that is in polar form. Go ahead and pause the video and take a try at it. Okay, just like we've done before, we're going to graph it. So that'd be down here. So that's the point negative root 5, negative root 5. So you're going to determine R. So negative root 5 squared plus, oopsie, wrong thing. There we go. Negative root 5 squared. So R then is going to be 5 plus 5. So R is the square root of 10. Now we got to go ahead and figure out what theta is going to be here. So theta is negative root 5 over negative root 5. So that means tangent of theta equals 1. So if tangent of theta equals 1, then friends, what we're looking at here is this is going to either be pi over 4. And when you do it on your calculator will say pi over 4 or 45 degrees. That's why we always graph it, or 5 pi over 4. So we look at our graph to make sure we know exactly which one we want. In this case, we want 5 pi over 4. So we go ahead and we plug it in here then. That means in polar form, this would have been root 10, comma, 5 pi over 4. All right, so we've converted points. That's not the only thing we can convert. We can also convert equations. So when you're converting equations, when you're going from rectangular to polar, all it means is wherever your x and y are, we want to get rid of x and y. So rectangular, and we're going to put it into polar. So I'm going to take every x and y, and I'm going to put it in terms of r and theta. So this is where this comes into play. We know that x is r cosine of theta. We know that y is r sine of theta. So we're going to go ahead and get rid of our x's. And we're going to get rid of our y's. So let's see here. X was r cosine theta. And y is r sine theta. So in other words, we're going to factor out the r here. So I have r times negative 4 cosine theta plus 13 sine theta. So we factor the r out of it. And then we're going to divide by it. So r is 6. This would be what a linear function would look like in polar form. And tomorrow, I'm not going to give you guys a book assignment over, but I am going to go over, have you guys watch a video where we just do some basic polar graphs so you can kind of see what some of these graphs might look like. Because some are kind of fun, honestly. They're fun to put in your graphing calculator and just to see what they kind of look like. Because a lot of them look like flowers and stuff. You can make one look like a heart and different things like that. It's kind of cool. All right, so we got r by itself. It's like y. We only want one y if we can. We only want one r. So we divide it out and we end up getting r by itself. Well, I'd love to let you guys try this. Try one. What if I give you this line? Y equals x. What I want you guys to do, we'll call this one 7.5. How's that one for you? A little extra. I want you guys to go ahead and write that in terms and put it into its polar form. Go for it. All right, let's see here. If I want to get it in polar form, I see I have just both a single y and a single x. So what if I divide both of these by x? I'd have y over x equals 1. Well, that's tangent of theta equals 1. So I can write it like that, or another way to write it, and this is probably a better way to write it, we can go ahead and solve that. Theta equals pi over 4. All right. Well, friends, our final thing is how do we convert from polar coordinates to a rectangular coordinate? I'm only going to give you one example of this. So I'd like you guys to try it a little bit. Here's my one little hint for you. Think about cross multiplying. Let you guys go ahead and try it and see what you come up with, and then we'll go from there. All right, let's see how you did. So I see I have r times 1 is r plus r sine theta equals 2. Well, r sine theta is y. So how about in place of that r sine theta, I change it to y. I'll deal with that r in a second. I don't really want to deal with it quite yet. I am going to move the y to the other side, though. So I have r2 minus y. I could do a square root, but I really want to avoid it. I do kind of like this idea of r squared. So what if I were to square both sides? So I square here, and I square here, like that. I end up with r squared equals 4 minus 4y plus y squared. Now, friends, I know what r squared equals. That's x squared plus y squared. So I'm going to plug that in here. I've now officially gotten rid of all my r's and thetas, so I did what I wanted to do. But now I'm going to go ahead and take my equation here and see if I can either solve for y or get one side equal to 0. In this case, I'm going to go ahead and get one side equal to 0. So if I were to do that here, let's see here, I would end up with, well, actually, we'll go ahead and get, we can solve this one for y, it looks like. So we have x squared equals 4 minus 4y. So that means then that 4y, and I'm just going to have the x squared and the y 4 and the 4y change sides there. So I got 4y equals negative x squared plus 4. So if I divide everything by 4, I get y equals negative 1/4 x squared plus 1. Turns out what we have there with r equals 2 times, or 2 over 1 plus sine theta, that's just a parabola, friends. All righty. Well, friends, that kind of takes care of what we're dealing with today. So we'll talk more about this in class. These are actually kind of fun, just kind of going back and forth. The biggest thing to remember, and friends, you're going to want to keep this in front of you the entire time. Don't lose this. You'll always come back to this right here. And honestly, you'll come back to that whether it's vectors, complex numbers, or polar coordinates. You always come back to that. So we'll see you tomorrow morning, and we'll talk a little bit more about this in class. Take care.